Okay, so looking at your blue sheet, ladies and gentlemen, on the front side, these are the problems. The very last one, number 5, these are the ones we're going to talk about in the last and final section of Unit 4. These are called your double angle identities. The double angles are recognizable. We call them double angle because you're taking theta, which is an angle, and you're multiplying by 2. Remember, anytime you multiply something by 2, you're doubling it. That's why we call it the double angle. So your double angle formula for sine is 2 sine theta cosine theta. The cosine of 2 theta, and there's 3 variations of this particular formula. I just typically always stick with the first, cosine squared minus sine squared. Now, remember notation-wise, what does it mean when you have a trig function squared? You're going to take the cosine of theta, whatever that value is, and you square it. That's what that notation means, minus the sine of theta squared. The tangent of 2 theta goes back to your quotient identity. Remember, your quotient identity, tangent's equal to sine over cosine. So the tangent of 2 theta is just the sine of 2 theta divided by the cosine of 2 theta. So these are your double angle formulas for sine, cosine, and tangent. Yes, George, yeah.
Oh, so for the cosine ones, where did you get like the other 2 here?
So it goes back to your Pythagorean identity substitution. So for example, by your Pythagorean identity, what is sine squared equal to? Sine squared is equal to 1 minus cosine squared. So I can take the cosine squared of theta minus, take out sine squared, and replace it with a 1 minus cosine squared of theta. So again, when I distribute the negative, that becomes a minus 1, that becomes a positive. So cosine squared plus cosine squared gives me a 2 cosine squared theta minus 1. Or you could do vice versa. Instead of changing the sine squared, I can then replace cosine squared with a 1 minus sine squared. So I could write this as a 1 minus sine squared, so that takes care of where that one came from. So I could change that cosine squared to 1 minus sine squared theta minus sine squared theta, which gives me 1 minus 2 sine squared. Do you have to memorize all 3 versions? No. If you want to, again, where do they come from? You can derive them by your Pythagorean identities. But if you know the first one, you'll be able to do the problems. Okay? All right. So like I said, double angles happen when 2 angles have the same angle. These cases are called double angle identities. And again, I'm not going to fill in this box. I'm just going to write C your blue sheet. Identity is number 5. Okay? Yeah.
Do we have to memorize?
Yes. Remember, anything on the front side you have to memorize. The back side you don't. Okay? So now, these are mainly all triangle problems. So they want me to find the sine, cosine, and tangent. Given that the cosine of theta is negative 5 over 13, and theta is between pi and 3 pi over 2. So just like we did with sum and difference, guess what you're going to have to draw first? You have to draw your triangles. Again, guys, don't mess up drawing your triangle. Make sure you get the location, location, location correct. Look at your location. The angle has to be between pi and 3 pi over 2. So what does that tell you? What quadrant are we going to draw the triangle? 3. So this is the 3rd quadrant. So now they're giving me that the cosine is negative 5 over 13. So going back to your SOHCAHTOA, what sides of the triangle does this represent? This represents the adjacent over the hypotenuse. So here's my adjacent side of 5, 13. Where does the negative sign go? In front of the 5 or the 13? The 5. You're on the negative side of the x-axis. Remember, the hypotenuses are always positive. So now, how are you going to find your 3rd side of the triangle? You have to use your Pythagorean theorem, or if you remember your Pythagorean triples from geometry. What is the 3rd side of this triangle going to be? 12. Do you need a negative sign in front of the 12? Yes, because you're on the negative side of the y-axis. So any questions on how I've labeled my triangle? So just like I did with the sum and difference, I'm going to go ahead and set up the sine and the tangent. So sine, remember, is the opposite over hypotenuse, which is negative 12 over 13. Tangent is the opposite over adjacent, and a negative over a negative becomes a positive. You're in the third quadrant, guys. What are the only two positive trig functions in quadrant 3? Tangent. Sine and cosine, make sure you have the negative signs. So any questions, guys, on how I set up the cosine, sine, or tangent from the triangle? Now you're ready to go ahead and find your double angle. So the sine of 2 theta. So looking on your blue sheet, the double angle formula sine is 2 sine theta cosine theta. So remember, 2 is actually a fraction. What's the denominator for 2 even though it's not written? 1. So 2 over 1 times sine of theta. What did we say the sine of theta was? The sine of theta is negative 12 over 13. Times the cosine of theta. We found the cosine of theta was given to us as negative 5 over 13. If you can multiply 2 fractions together, you can multiply 3 fractions together. Remember, you just multiply straight across. So, again, it doesn't matter. Negative 5 times negative 12 is 60. 60 times 2 is 120. 13 times 1 is a 169. So there's your double angle for sine. Again, we can't reduce the fraction. Reduce if you can, but you can't reduce 120 over 169. So any questions on using the sine double angle formula? So you'll probably find that they're a little bit easier to use than the sum and difference. Cosine. So cosine of 2 theta, again, is the cosine squared of theta minus sine squared of theta. Now remember, like I mentioned, what this notation means. You're taking something and you're going to square the quantity. That's what this cosine squared means. So again, find the cosine of theta. The cosine of theta was given to us as negative 5 over 13. Minus. Do the same thing with your sine ratio. The sine of theta is negative 12 over 13. So any questions on how I substituted into the cosine double angle? How do you square a fraction? Square the numerator and the denominator. What happens when you square negative? It becomes a positive. So when I square negative 5 over 13, that's going to become 25 over 169. Minus. Square your negative 12, that's going to be 144 over 169. The denominators are already the same, so go ahead and subtract the numerators. 25 minus 144 is going to give me negative 119 over 169. Okay? So any questions on how the cosine double angle formula works? Last one. Just go off to the side since I ran out of room. Tangent. Tangent, using your quotient identity, I know is sine over cosine. So the tangent of 2 theta is going to be the sine of 2 theta, which we already know, over the cosine of 2 theta. So remember, we found the first one, we found the sine of 2 theta to be 120 over 169. Remember, this fraction bar means I'm dividing. I'm dividing by the cosine of 2 theta. I just found the cosine of 2 theta to be negative 119 over 169. How do you divide fractions? How do you divide fractions? You're going to do what? Multiply by the reciprocal. And notice you can cross cancel the 169s. And you're left with negative 120 over 119. So any questions on how the double angle formulas work for sine, cosine, or tangent? Okay. You guys go ahead for me in number 2. set up your triangles and find the, label your triangle and use your Pythagorean theorem, and then we'll, before we go on. Again, guys, I can't emphasize enough.